Hello everybody and welcome back. We're looking at the next four questions on our 2016 midterm, so this will be 17, 18, 19, and 20. Alright, so question 17. How many horizontal asymptotes does f of x equal to e to the ln of e to the 2x have? Alright, now this part here, it just looks very complicated, so is there anything we can do to better understand this expression? Well, absolutely. We might remember our logarithm rules, that an exponent inside, this 2x, can come outside. And then ln e, well, ln of e is just 1, because ln is really just log base e. And if you plug the base into any logarithm with that base, you get 1. Log base b of b is always 1, and so ln e is always 1. So really the ln e goes away and we're left with e to the 2x. So this was just a fancy way of writing e to the 2x. Now in terms of horizontal asymptotes, I'm going to use my exponent rules. Just rewrite this as e squared to the power of x. Now the reason I'm doing this is just to help emphasize that what we've got here is a function that looks like b to the x, a normal exponential function. The base here is e squared, which I believe is about... what is it? It's a little less than 9, so it's about, about 7.7 and a quarter, I think is what it is. But we've got a nice little exponential function. How many horizontal asymptotes do exponential functions have? Well, they always have 1. Y equals 0. So our answer is just going to be B, or I guess we'll circle it. 1 horizontal asymptote, and there we go. I'd just like to re-emphasize something, a point that I make in class every once in a while. These answers of 3 and more than 3 are impossible. No function can have more than 2 horizontal asymptotes, because you can get one heading left and one heading right, but that's it. It's not like vertical asymptotes where you can have really as many as you want. Alright, so 18. Determine the equation of the tangent line to the curve y equals 3x squared at the point 327. Notice the form of the line we've got here is point slope form of the line rather than y equals mx plus b form. What do I need? I need the point on the line. And then I need the slope, m. Okay? But even just writing it like this, I can see that, oh gosh, I guess D is really the only option here. That's kind of nifty. But we'll go through the question as though whoever made this one didn't sort of screw it up. Yeah, it's really embarrassing that, well, I guess it pays to know point slope form of the line. Anyway, let's get the slope. So our m value, that's the slope. So we just want to take the derivative of our function, 3x squared. So that'll be the 2 comes down, 2 times 3 is 6. So it'll be 6x. And we want to evaluate that at our a value 3. So we evaluate at x equals 3. 6 times 3 is 18. So in place of our m here, we should just get 18. And that does track with what D is. So there we go. All right, nice short question. 19. The limit x tends to 4 of root x minus 4 over root x minus 2 over x minus 4 represents the derivative of a function f of x at a point A. The pair f of x and A is... So they want me to find the function and the particular value. Okay. So one thing we could do, so this is a first principles derivative. We are given options here. We could try and first principles and set up each one of these. I think when we are confronted with a question like this, the smarter thing to do is take what we're given and compare it to our known first principles forms. So there's 2 basic first principles forms of the derivative. Here's one. And here's the other. The second one I'm writing here is the one that's more preferable for calculations, especially for trig functions or exponential functions by first principles. But when I take a look at what I've got, my variable is not tending to 0. So I'm actually not looking at one of these by first principles. I'm looking at one of these, the limit as x approaches a. And as soon as I make that connection, well, what is my x approaching here? 4. So a had better be 4. And so that allows me to clean things up a little bit. We're looking at the limit as x approaches 4 of f of x minus f at 4 over x minus 4. Now, we can also narrow down that it's definitely not going to be a, because that a value is 2. We're looking at b, c, or d. Now, do either of these as my function, when I compute f at 4, spit out 2? Well, comparing to our form up here again, we have f of x minus f at 4 on top. So, if I'm right, f of x is just going to be root x. And double check, f at 4, root 4 is 2. So, yeah, that seems to work. Do any of these options have my function as root x? B does. And there we go. All right, the last question for this video. Question 20. Which of the following represents a derivative? So it's almost the exact same thing we were talking about before, and I believe you guys have had this on a quiz question. A quiz, I think it was our second quiz, had this type of a question. I was the one who made this question up this year, and I do like this question. All right, so we have a lot of options. There's the x tending to a's, there's the h tending to zeros. Okay, and so we only know 2 forms of first principles derivatives. So quickly scroll those down and see, have we got either of those present? Now we've got an x tending to a here, but it's an f of x plus a minus f of x and then an x minus a, so not quite. We've got an h tending to a little weird, but okay. F of, well, no, we don't have the x minus the variable minus what you're tending to down here, so d's out. If we look at a, it actually matches up exactly with what we've got. So a is the answer. Just quickly, why doesn't c work? It's still got the f of x plus h and the f of x and the dividing by h, but it's not h tending to 0. So it doesn't quite fit the mold. And there we go. So a is going to be our answer for question 20, and we'll look at 21 through 24 in the next video. So I will see you there. Until then, take care.